Hey everybody. Today we're doing some hypothesis testing in R using the t.test command. We're going to work through a couple of problems relating to the built-in air quality dataset, which we're going to view as representing a simple random sample of air quality measurements from New York City. Problem 1. An official claims that the average wind speed in the city is 9 miles per hour. Is this plausible in light of the data? So let's swap over to R, where I've already loaded up tidyverse. I do that reflexively at the start of each of my R sessions. I've also pulled up the help file for the air quality data set. You can see that this data was collected in 1973, so it's not exactly fresh data. We can also use the view command, for instance, to take a look at the set itself. Here we see that we have 153 observations on 6 variables, including wind and solar radiation, the two that I'm going to be interested in. Before we do any sort of statistical test, I think it's good statistical practice for us to graph our data, to visualize it. So let's do that with a histogram. I just need something rough and ready for, I just want a visualization for this single variable, so I'm going to use the qplot command. Air quality, $wind, and I'll explicitly let R know that the geom I want is histogram. Okay. So the null hypothesis in this case is that the mean wind speed is 9 miles per hour. And as I glance at this histogram, it's at least plausible that that could be the case, although the histogram does seem to be centered just a little bit to the right of that. The question is, if the null hypothesis is true, could that difference be just due to random chance? Would that be plausible or not? So we want to test that with a significance test using the t-distribution. The command here is t.test. First of all, we have to pass the vector that we're interested in doing a significance test on, and that's, of course, going to be air quality, $wind. Next, we need to let R know what the null hypothesis is here. Here, the null hypothesis is that the mean wind speed is 9. The syntax is mu equals 9. And that's all we really need here. R will do a two-sided alternative hypothesis by default. So here we see that the sample mean is 9.96. So just as we observed in that histogram, the sample mean is a little bit higher than the value from the null hypothesis. The t-statistic of that sample mean is 3.36, which corresponds to a p-value of just under 0.1%. Very small p-value. Given that very small p-value, it's not plausible that this data varies from the null hypothesis by this much just due to random chance. We're safe to reject the null hypothesis and conclude that, in fact, the mean wind speed in New York is not 9 miles per hour. Problem 2. A certain solar array will only be cost-effective if mean solar radiation is over 175 Langleys. Would this be a sound investment in light of this data? Here we're wanting to test a one-sided alternative. Our null hypothesis is going to be that the mean is 175 Langleys, and the alternative hypothesis is going to be that it's greater. Again, let's start by visualizing our data. So qplot air quality, $solar radiation. Again, I'll say geom equal histogram, just out of habit. Once again, you can see that the null hypothesis claim is at least plausible, visually speaking. Although, again, if we squint, it does look like the center of this histogram, again, is a little bit to the right of that. So again, let's do a t-test on this. It's air quality, $solar radiation this time. The null hypothesis value is 175. Since we want an alternative hypothesis to be one-sided, in particular that the true population mean is greater than 175, we have to specify an additional argument. And here the argument we need is alternative equals, quote, greater. You do need to spell greater correctly, however. There we go. Okay, so in this case, the sample mean was 185.9, which corresponded to a t-statistic of 1.47. and a p-value of 0.07. So if the null hypothesis is true, a sample mean like this would occur by chance more than 7% of the time. So this is not compelling evidence that the mean solar radiation in New York is over 175, the threshold that we would need to justify this purchase. We should draw no conclusions about the mean solar radiation being greater than 175 or not. We need to do some further study in order to justify this purchase.